Hello students, welcome back. So far we defined and studied Riemann sums along with the visualization. Now let's go to some exercises on Riemann sums before going over to the Riemann integrals. So before this, let's do this one first. So let's switch the order. There you go, and let's do this one first. Express the given picture as a Riemann sum of the function f in the interval -4 to 12, and here's the picture. So -4 to 12, and apparently we have 4 rectangles added up, so that's got to be the Riemann sum. First area, second area, third area, and fourth area, and please recognize that the width of all these rectangles are all the same. There are 4. Do you see it? So Riemann sum is sum of the areas of these rectangles. So basically this is width times height. Okay, what is the width? That's 4, isn't it? And height of the first rectangle here, what is it? Function value is given by f of -2. Do you see that? That's the first. Next, width is 4, and then function value is f of 2. Is that clear? Next, width is again 4, and function value is 6. I'm taking the midpoint approximation. That's the height. And finally, 4 times f of 10. That's the Riemann sum. I did not give you any algebraic expression of this function, and I did not give you any other number here, so there's no way to approximate this thing any further. Now, what if I did give you something? Let's see, what is this function? Okay, all right, let's suppose I did give you something. Okay, my function here is f of x is x sine of 0.05x squared minus 1.0x plus 1.5 exponential of e to the x over 10 minus 5 e to the negative x minus 10 squared plus 3. Oops. Okay, that's my function. I used traditional form. And then, of course, you're looking for the definite integral. -4 to 12 f of x dx. And then trying to calculate this using fundamental theorem of calculus, hey, that's crazy. And then you can use mathematical command, numerical integration. X is going from -4 to 12. This way you can get pretty good approximation, 132.938. But then again, it is possible to approximate this as this quantity. Interesting. If you do this, what do you get? Shall we do your computation? So 4 times f of -2 plus f of 2 after factoring out f of 6 plus f of 10. That quantity is 112.499. So you can do it like this. Why am I doing this? I should have just copy and pasted. So if I give you algebraic expression of the function, but completely uncalculatable by design, then you can get Riemann sum expression and punch these into calculator and get some approximate value. That'll be the end of the solution, okay? If I did not give you algebraic expression of the function, then this expression will complete the problem. Make sense? If this were there, then I'm asking for one more step. This. I mean, put these into calculator and run it. And if this is not there, then it's easy. You can stop here. In this original problem, this expression was not there. So it was an easy problem as a matter of fact. And computation, that too is not a difficult problem either, just tedious. Okay, next. Instead of midpoint approximation, we have left-hand side approximation. Left-hand side endpoint, left-hand side endpoint, left-hand side endpoint, left-hand side endpoint. Can you do this on your own? Well, widths are all four, the same as before. And then instead of midpoints, f of -2, f of 2, f of 6, f of 10, respectively, we get left-hand side point. So if you put everything, what do you get? Stop the playback and write down your solution. Did you? Okay, here's the answer. Did you get it? 4 is the width, all together, all the same, and left-hand side endpoint, f of -4, f of 0, f of 4, f of 8. That was easy, right? And I could have given you right-hand side endpoint problem, but it's a bit repetitive, so I gave you this problem. This time we have variable width. So first rectangle has width 1, and then next rectangle has 1, 2, 3, 4, 5, and so on. Count and get widths, and then heights at -4, -2, +5, +10. Okay, all right. It's a matter of writing things down. Did you get it? Well, that's the answer. Okay. All right. So much for an exercise problem on a Riemann sum. Next time, we're going to discuss Riemann integral.